So it's a live hacking session. We're talking about securing application workloads on AWS using Snyk. And just to introduce you to the speakers, today we've got with us Eric. Would you like to just quickly introduce yourself?
Sure. So Eric Smalling in the Dallas-Fort Worth area. I'm a senior developer advocate here at Snyk. I've been here about 3 years, and I have a background in software development. The last decade or so, before joining Snyk, I was more in the DevOpsy space, doing consulting, professional services stuff. I'm a Docker captain, and have been using Docker since the early days, as you see in the slide there. And I had to cross out my CKS cert. I am certified in the other two, but I need to renew my CKS. It just expired. So that's my next project.
Well, that is very organized of you to realize it was expired. Yep. So I'm Paul Harland. I'm a channel solutions engineer here at Snyk, helping our partners understand and basically show the customers and build our platform into their services offerings. I've been a software engineer for about 15 years, starting in some various very early languages like Fortran and Perl, and moving up to some of the later languages later in my career. But now I've been in sales engineering for about 10 years, and I'm taking you through really the understanding of the platform today. So a little bit about what we're doing today. I'll introduce you to what the session will be like and a little bit about the Snyk platform. We'll then go into the live hacking workshop and then talk about actually what we've learned today and how that practice can be taken back to our jobs to make us more secure. We'll also answer any questions as we go along, either at the time we spot them or we'll wait until the end to do that as well. There are a few things you'll need if you want to do this workshop. However, as Eric says, we'll be going quite fast today. So it may be that once the video is released, you can watch the video along with these prerequisites and actually do the workshop yourself. So you'll need a Snyk account, access to the workshop, which is just a website there, and also an AWS account, either your free account that you create or one that's given to you by work. You also need to understand not too much, but a little bit about how to deploy applications on the cloud. Okay, so Snyk, if you've not come across Snyk before, it's an application security platform. It's a developer-first application security platform, helping the developers understand and make the right decisions in all the layers of their modern cloud applications. So we're looking at the code that the developers write, the open source components that they include, the containers that them artifacts get deployed upon, and the infrastructure as code, which creates the cloud instances where those containers are then served to your customers. But we do this in a number of different integration places, not just as a web SaaS offering. We integrate into the SCM tools where your code is stored. When you then check that work out onto your local IDE, again, we're integrated there, helping you create new, as you create new features, helping you do that in a secure way. When it's time to commit that work back to your main repository, again, we're checking the pull requests and making sure that you're not pushing any vulnerabilities into your code. That then usually kicks off a CI/CD build. Again, Snyk's in there, making sure that no vulnerable artifacts make it through to live. We can then scan those registry artifacts, either container or your applications, and also look at your live cloud environment as well. But Snyk is all about showing the developer really what they can do to be more secure. When we show a developer a vulnerability, it's all about prioritization, help with remediation, and then education. We think the best vulnerability removal tool is education so that you don't actually make those mistakes or understand them before you push them in the first place. But as we're talking about AWS, what I'd like to highlight is the number of different integrations that we've already got within the AWS sphere and that we're building into the future as well. So when you're scanning your code and push it into code commit, we can integrate into code pipeline and check your builds as they're pushing through code pipeline. We're the only security tool that's integrated there. We can scan your ECR containers. We can also integrate into your EKS clusters. Added to that, we've got a number of integrations which help your security and observability team as well. EventBridge, CloudTrail Lake, Security Hub, and one of the data sources actually on Amazon Inspector is also Snyk, showing that the database that backs up our platform is industry trusted. Now, when we're looking at modern development, we see the real need for really a scalable tool, a tool that's enterprise grade and a tool that helps teams collaborate in terms of how to be more secure. And that's because developers are introducing code a lot faster now. It used to just be a single monolith, but now developers are versioning and creating separate parts of that or components of that application separately, often versioned separately, maybe even with different CI/CD pipelines, off into the cloud multiple times per day. That means more code is getting created. Also, applications are more complex than before. It's not just the application code that you're writing, the business logic. It's also the open source that you're pulling in, the containers you're deploying it on, and the infrastructure that you're also creating, amending, or updating as well. And also the number and complexity of these issues, they just goes up all the time. We're finding more and more vulnerabilities because it's not just us as developers for our businesses who are writing more software. Open source components are also being created faster, more. There's new languages, ecosystems, frameworks, and all of these, when they're used, they can be spotted with vulnerabilities, and Snyk helping in all of those areas there. And that's really why we're needing Snyk. And actually, we've done quite a few. We want to understand what Snyk is doing for our customers. So often we go out and speak to our customers after they've deployed Snyk and used it within their business. And we often create a lot of reports, which is reporting back from these customers who've used Snyk. And we found on the left-hand side here, which is quite an important one, 60% of organizations have increased security concerns since adopting cloud native. So if they've got increased security concerns, that means there's some unknowns to them. They think some things are out of their realm or they're not too sure what's going on. Having an enterprise grade platform that can help them understand these vulnerabilities will really bring that surety back to them. And here we go, another great one. Over 56% experienced a misconfiguration or known unpatched vulnerability involving their cloud native applications. And this can come, as Eric's going to show today, either in the application that you're writing or sometimes just on the container that you're using to host that application. And you'll see at the bottom, I've actually saved a link to that report so that you can read it in full yourselves. On the right-hand side, we can look here, infrastructure as code reduces misconfigurations by 70%. What Snyk's attempting to do is not just make your cloud applications more secure, in that you can go to the cloud and make the changes. We always want to tie that back into how do we change the Terraform? How do we change the cloud formation script in order to make that application more secure? That way, every single time it's deployed, it is deployed in a secure manner. So rather than doing the click ops, which is changing things that are already on the cloud, Snyk wants to drive back to changing the original infrastructure as code to help you make that more secure as you go along as well. Okay, that's it. I was told you I'd be very quick on the slides. We've got to save time for the workshop. So that is the workshop again. Just briefly, what we're going to do in the workshop before I hand over to Eric. We're going to build an application using the provided images and repositories that we have. We're then going to deploy that into our EKS cluster. Once we've done that, we're then going to exploit a vulnerability that we found in the container layer. And that's quite an interesting one, actually. And then we're going to exploit a vulnerability on the application layer. We're then going to fix those vulnerabilities and show that they're no longer hackable as well. So not only do you learn about actual vulnerabilities, you're learning how to hack them and how to prevent them as well. This is going to be a lot of fun. Over to you, Eric. Can't wait to see this.
Get my microphone unmuted and get my screen share going here. While I'm doing that, I think we had one question in the Q&A section. It says, we mentioned EKS, but what about ECS? You want to talk to that while I get my screen share going?
So we integrate into your ECR to actually scan your containers before they get deployed to Elastic Container Service. So the way we'd probably do that is either scanning your Docker files before you actually scan, before you actually deploy the container. Once you've got the image and it's going through your CI/CD, we can also scan it there. And then when it goes to ECR, we can also integrate there and scan. So there's lots of different ways where we'd want to scan that, but it results in it's still the same image wherever it is.
Awesome. Okay, well, as Paul said, we've got a very tight timeline here, so I'm going to get going. And the first thing I'm going to say is you're probably going to be like, "You're going too fast. I can't keep up." Catch the video afterwards where you'll be able to pause me and watch again. But if you can follow along, that's great. But if you go to, I'm going to try to keep this at the bottom of the screen. That URL that will redirect you to this workshop, and it will walk you through setup and the whole narrative of getting through everything. We're going to go through all these modules. The fourth module is kind of a bonus. We're not going to hit that today. We just don't have time. We set that one up for a longer workshop we had done before, and we just left it in here for you. That deals with our technical partners over at ChainGuard and some of the images they have. You might check that out on your own time for more stuff. So the first thing we're going to do is there is a prerequisite session that I've already done ahead of time, kind of like a cooking show. I've already baked this part of it, which will walk you through. In this case, you're going to be on your own, making sure you have an AWS account, getting your workspace and permissions and all set up. So what you're going to want to end up having is a Cloud9 IDE and an EKS cluster that it has permissions to talk to. That's what all of that does. And you'll end up here at the end of that with getting a repository, which is our demonstration application for this. And I'm going to pause here for a second and say that anytime a Snyk employee or anybody at Snyk or you're reading any of our blogs mentions a goof repository, if you deploy this anywhere, make sure it is in a sandbox somewhere not important, because most of these have vulnerabilities in them because they're demonstrations. Don't put this in your corporate clusters that that you wouldn't otherwise want a known vulnerable application going into. In fact, if I deploy this into my DevRel cluster and make it exposed, within moments, our own Snyk operations folks get a hold of me. It's happened several times. It happened at reInvent last week when I was doing a demo live, and they're like, "Hey, what's that?"
I've had that experience a few times as well. Yeah, they are intentionally vulnerable, so watch out.
Yep. So yeah, don't put this next to anything you care about. So what you're going to do is you're going to go to GitHub. The link is here, and you'll see this Snyk Partners Goof application. And you're going to create a new repository off of it. It's what we call a template. It's kind of like forking, but in this case, you're just creating a copy without the history behind it. You're going to create that in your organization. Call it Goof if you want to. If you call it Goof, all the steps in this workflow will just work. And make sure it's public. Okay, you can hit create, and once that is done, let's go over to our Cloud9 environment. So here I am in the AWS console. I have created my Cloud9 in the prerequisite steps I didn't show you. I'm going to open that IDE, which I already have in another tab. It's going to look something like this. You might have a welcome page or tab or something. You can close that down to clean things up. And you're going to clone the application that we just made the copy of in your repository over. For ease of workflow, I have an environment variable set up so that I can just copy and paste things. You don't necessarily have to do that, but just basically do your normal git clone, get that repository, and cd into it. This is where I am. I have that. And then to get Cloud9 IDE and environment set up for our demonstration, there's a simple script to run. So if you were to cd into the Cloud9 setup directory, you'll see a few things in there. That setup script is what you want to run. So if you're going to go in there, you're going to run the setup, and then at the end, you're going to source the bash RC file that it has updated. And that way, all of your environmental variables and everything else are set and in place. I've already done that in this case, and I know that because things like kubectl is aliased to K. As long as that works for you, you know that you've sourced that your environment is set up correctly. In fact, at that point, I should be able to say kubectl get nodes, and I should successfully see my EKS cluster here. If that's not working for you, we walk you through a little bit of troubleshooting. You need to take a look and make sure. The usual problem is that your kube config, if this is like an older environment you may be using, you might be pointing to another cluster or something else. Make sure your EKS cluster is the one that you're pointing to. That being said, Paul mentioned we're going to want to have a Snyk account and configure it here. So if you haven't signed up for Snyk yet, you can click this link and it'll take you to the Snyk login. I'm logged in, so it's going to pop me into my account. It'll walk you through creating an account if you don't already have one, or it'll prompt you to log into one if you do. And once you've done that, we're gonna set up the CLI. Now we're taking from this link. This is the full instructions on how to install it. But if you just copy these steps, this is going to go get the latest Snyk CLI binary, bring it down and set it up in the right place in your path with permissions, which I have already done. I could type Snyk and I should get the help for it in a moment. There we go. So you do that, and then you need to set it up with your API token, your auth token, I should say. So I've done that already, but I'll show you. We walk you through how to do this, but I'll show you in the interface. I'm going to skip this intro here. You go to your account settings. Now I'm not going to click this and show you my auth token, but if I click this field right here, it will show me my token. I copy that, come back over here, type as the instructions show, type Snyk auth and paste that in, and you'll get something looking like this. So now you're all configured. Your Snyk CLI is set up to talk to our backend APIs. And the reason you need to have an account for this is because the Snyk vulnerability database is a SaaS service. When you run any kind of our scans, it's always going to be querying back into that database because it's constantly being updated. And there's other reasons that you need to have an account, because you can have organizational settings that you want all your developers on your team to share and things like that. But just know that for this demo, you need to get past that step to be able to move forward. So I know that was fast, but you'll be able to do it if you follow through those steps. Let's jump right into module 1. So we are going to build our goof container image. So there's 3 repositories, 3 images we're going to create. So we need 3 ECR repositories to hold them in order to deploy them to EKS. This command is going to do that. It's going to create all 3 of these, and it gives them the names that you see there. So I'm going to copy that here on my screen, and I'm going to CD out of that Cloud9 setup directory because I don't want to be there. And here we go. So this is running, and it's going to create all 3 of those repositories. And you should see, like you saw, that JSON output come out. Now we want to grab the portion of that is unique to you, the repository URI, the part that's before the image name. And we're going to hold that in a variable called repo so we can use that throughout the workshop. This command will do that. It's kind of using some variables that are available to us. So there we go. So we now have that repo variable set in this shell. If you were to close this shell and open a new one, make sure you go back and do this again, or else the copy pasting from the workshop will not work because you won't have that variable anymore. So now we need to set Docker up, the Docker client, to be able to log into my ECR repositories. And this handy AWS command will do that. It gets the login password and pipes it into the Docker login. So I'm going to copy that, paste it in here, and you'll see login succeeded. And finally, let's build those images. So this is the 3 different build commands that are going to go into each one of these directories that are subdirectories in that repository we cloned, and build them. And it's going to tag them with that repository name and the image name. And it's just going to put latest as the final tag. So clear the screen, and this should be pretty fast because I've cached some things up beforehand. There we go. Probably takes a little longer for you the first time as it pulls down image layers for the base images and whatnot, and all the things you're probably used to with Docker. If we do a Docker images now, or image ls if you like it that way, you'll see I have the 3 images. It says it's cached from prior layers, so it's saying 19 hours ago. But there's my 3 images that I've built. So now, of course, we need to push these up to our new repositories we just created in ECR. These 3 Docker pushes will do that. These are new repositories, so this will take a moment while it pushes all the layers up there. When we're done, I'm going to go ahead and click this now. We're going to go into our UI just to make sure we can see them. And the usual thing for me, since I don't often use US West, is you're seeing I'm defaulting to Ohio. I need to come in and go to US West, which is what our workshop is using. And I'm going to see there's my 3 repositories right there. So I can kind of visually tell that I've got those repositories created. And come on. It should be faster since it's right in the
Yeah,
data.
it's usually quite fast because it's just an internal um, transfer from Cloud9 AWS to ECR
That's
AWS.
okay. It knows I'm
So,
doing a live demo. That's
yes,
perfect. Let's mess with Eric today.
I
He
think
is
because it's the event engine, they may put a choke on the speed it can do transfers.
that's actually probably true. So the
Yeah.
first one, what was that? That was the thumbnailer. Let's go just out of curiosity. We can look and there it is. So it's working and it's pushing it where I intended it to go. While that's going, I'm going to move forward to the next step. Well, so we don't sit here and stare at a shell. So walking through what we're going to do next. Now we want to deploy this to our cluster. We want to put it in its own namespace to be friendly. We're going to create a namespace called Snyk AWS, and we're going to change our kube config to have that be our default content in our context, that to be the namespace we're dealing with by default. And then finally, I'm going to talk about this one. This is an interesting command you may not have seen before. We're using the env subst Linux command to take that repo variable and substitute it in place in all of our manifests for this deployment. So if you were to open those, show you what that looks like while that's still running. If I go into manifests and we'll look at like thumbnailer. This is just a little trick I do for demos like this. So there's the image name repo thumbnailer. When I pipe that through with this cat all the manifests through that, it'll take any environmental variable that it sees in the YAML and it'll just replace it, and then we're piping it through and using standard in to kubectl. So a little hacky way rather than setting up a whole customize or some other kind of templating system. This is the simple one. So let's see. I have stalled enough time. The pushes are done. So close that. And let's create our namespace and set our config. So paste that.
We should say that the EKS cluster is pre-existing, so that
Yes.
is just there waiting for us to add a deployment namespace to it.
Yep. That's part of those Pre-Reqs steps is to deploy the EKS cluster. You can do that with EKS CTL, which is how I normally do it, or through the UI if you like. So we're going to head now do the magic cat command, and we should see a bunch of resources get created. There we go. No errors came up. Let's take a look at what we have now. We're going to do a get all, kubectl get all. And because it was actually pretty fast. You should see pretty much what you see here. We have two pods, which are part of the two deployments that own them, both of them running. So if you still see container creating here, you want to wait a moment and wait for that to finish. You can just keep checking it again. You can do a get pod watch or get all again. But this tells me everything is up and running and we're good to go. Now, we have a couple load balanced services. We're using a load balancer to expose the services. The to-do list, because that's the app. The thumbnailer probably doesn't need a load balancer, but we use it just for this demo so we can make it easier to get to. So I'm going to copy this. We're going to grab the load balancer host names and put them into variables, again, for later ease of use. If I echo those out now, you'll see that we've grabbed both of those. So now we can just refer to that variable rather than A1FE, blah, blah, blah.
And I think there is actually a thumbnailer UI. We just don't use it in the demo, do we?
Yeah, there's a newer version that I need to update this demo with where we actually could tickle this vulnerability through a browser, but it takes a little longer. And with 60 minutes, I didn't want to go for that. Now, if you were eagle-eyed and you watched this while it was deploying, you saw some other things getting deployed. And this is because one of our exploits is being deployed into another namespace called dark web. And one of the bits of our exploit, I should say. This is a log4shell demonstration. So you'll see that in the second exploit we do. And this is the evil LDAP server that is hypothetically out somewhere else on a network. And we just use a namespace for it just to make it easy to demo. We'll talk
Love
about
the name evil.
Yeah. That actually is kind of what everyone in the 2 years ago when they were showing POCs of log4shell, everyone started calling it the evil server. And I was like, that works. We'll use that.
Yeah, why not?
Okay. So we have our app deployed. Let's go start taking a look at how to exploit and secure against the exploit. So the thumbnailer microservice is a simple Python-based web service, if you will, that takes a PNG image, probably any image, but PNG is what we're using, and it will shrink it down to a 100 by 100 thumbnail. Assume this would be used for like your avatar and your profile for a website or something. We don't want to store your, massive 4K version of your avatar. We're going to keep that little tiny thumbnail of it. To exploit this, if you're curious about details, we got a link in here to the actual CVE. You can go in and take a look at the POCs and information about it. But in a nutshell, what's happening is there is a way to take a PNG file and apply, I believe it's EXIF data, you apply a text record to it that will, when a certain tooling is used to do that manipulations on an image, it will see that and it'll actually try to access any path name that's in this text record. If that path on the server where that utility is running is readable, it will copy the contents of the file in that path into the EXIF data of the processed image. Let's take a look at it. So I've encapsulated how to do it into this exploit Python script, and I'll show that to you just so you can see that there's not really any magic here. Kind of is, but that's a pun. But if you see here, we have the encode. We have encode, decode, and upload. So the encode is doing a PNG crush is the utility we're using to load it in there, and then decode is using, where is it? Decode is using identify, which is another image manipulation tool. We could do those commands raw, but it's just faster just to run this script on it. So I'm going to go into my thumbnailer directory. And in this directory, I have this Kate's, Kubernetes PNG file. And it is literally just the Kubernetes logo. It's fairly big. We go full size. That's what we're going to send in to this microservice. So I'm going to use, but first I want to take, and I should just copy this rather than typing it. I'm going to, I already CD'd in, so I'm just going to copy this line. And you can see I am doing exploit py encode Kate's, and I'm putting in /etc/hosts. So our target here is we're trying to see the hosts file of the server service, or the process that is running the thumbnailer. So now I'm going to upload this. And this is pushing it to the thumbnailer load balancer. And you can see very quickly I got a result PNG. And if I open that, you can see it's a tiny version. This is 100% view. That's a tiny version of that thing. But if I decode that now, it's reaching in, looking at the EXIF data, and sure enough, that's the host file from the container that is running the thumbnailer service. So what we've got here, that's pretty bad considering if I knew what to look for, I could start exfiltrating information out of a service running potentially behind another web service, right? I could, in the other demo, if I were to do the long version, I can upload an image to the front end, it's calling on the back end, and I'm getting info about a deep thing. But what if we were to put something else in there instead of etc hosts? I'm going to do this. Go back up to the encode line. Anybody who knows Kubernetes knows that that is the path to the default location of the token for the service account that's running the pod. If it's not, if the person who has deployed this hasn't turned that feature off, because by default it's on, upload that. And just to show that there's nothing untoward here, keep current, close that. I'll look at the result PNG again. Again, it is just a thumbnail of that. But if we decode it now, that's a credential. I can use that as I try to expand and exploit. If I were able to get access to the API endpoint of this EKS cluster, I could potentially use this to try to get access to to the Kubernetes control plane. Now, luckily, we are running an EKS, and it is not as easy to do this. But if you're running on a roll your own cluster, just with kubeadm stand up, it is a very good possibility that if I could get at the kube API, which I can get to through the environment variables of a pod usually, I could use that to start poking around and see what else access on the API. So just know that, you know, data exfiltration is a bad problem. It's not just the remote code executions that are the problem. You're always going to watch out for that. So let's talk about how we could have found this. So let's go back to, let me clear this out. The Docker file for this service is right here. And you can see that this is deployed. It's a Python application, and the container is starting from a base of Python 3.11. And we're just doing a Flask install. It's a very simple web app. And I am going to do, let's see, I've got the image here. So actually, I should copy and paste. I'm going to use the Snyk API to scan that container, and I'm going to feed it the Docker file as metadata. So the Snyk container test, you can feed that in, and it helps it out with a little hinting more than it might be able to get just from the image. So it's analyzing the image itself, going through all the packages that are installed there, looking for fingerprints of possible other things. I've added an exclude app vulns because for time, I don't want to get too voluminous of an output here. I really just want to look at the container itself. So as a Python developer, I might not know a lot about operating system concerns or Docker or any of that stuff. But when I run, if I'm doing work on this container, and as part of my individual unit testing, I build the container to test it out, I can immediately run this test against it. And within a few seconds here, we're going to get the result back. Cloud 9 is not being nice here. This shouldn't take that long. There we go. Querying database. I think I've got a fairly small instance on my Cloud 9 here. So we see a lot of data did come out. There's a huge list, and a lot of scanners will give you that. They'll give you a big spreadsheet of CVEs. But what's really cool is the Snyk scanner will also tell you, hey, you are based on Python 3.11.1, and that comes to the table with 416 vulnerabilities. 9 of them critical, 32 high. Now, if I scroll up here, the thing that we're actually exploiting in my demonstration is an image magic vulnerability. It's one of these criticals. That image magic utility is being used by my Python application. It's shelling out to that and using that to do the image manipulations. Then we have recommendations, and it's coming and saying, hey, you could upgrade to one of these other base images and reduce your vulnerability counts. Now I'm looking at this. This is a little odd that it's showing 3.13. We're not going to use that because I don't want to go to a new dot version of Python. But I know I can go from 3.11.1 to 3.11.6 without any problems. Or even I could try Slim, but I think Slim doesn't have image magic, so that won't work for me. But I'm going to go ahead and go to 3.11.6 Bookworm. And honestly, I know Python. This is actually Bookworm as it is, so I'm just going to go to 3.11.6. I'm going to edit that script up there, or that Docker file up there. And as we're walking through, when I did this demo, it was 3.11.5. But I'm going to issue a new build while I'm in the thumbnail directory. Oops, move my cursor to the right spot. And this shouldn't take too long.
And one thing I always forget, always remember to save your file in code 9 before you do these deployments.
There is a setting that I have set here to automatically do that. So
well done.
If you go into settings under advanced or experimental, there's a setting to save on loss of focus. So I have done that. So there we go. The image build is done. Let's do a scan of it again. And we'll see what it looks like now that I've updated that base image. I'll take a drink of water while it's...
So the vulnerability was coming from something that was in the base image then, and it's the image magic library.
And that's the key thing here is, like I said, even if I'm a junior Docker person and I don't know much about containers or apt packages or anything like that, I can take that output and go to my architects, my leads, my AppSec folks and say, hey, this doesn't look good. Let's talk. And I can now have an educated discussion that I'm starting instead of waiting until like a week later when the audit happened and AppSec is like bang, bang, bang over my head. Like, what did you do? You've added you have a vulnerability here because of the base image you chose. I'm like, what? I don't understand. Here, it's a proactive.
We see that quite often now. The infrastructure team often creates golden images for developers, but developers use them every day. And if they've got valuable insight that suggests we should update something, they'd be more than willing to listen to that kind of collaborative work.
Yep. And there we go. So we're based on 3.11.6, and there is one critical vulnerability in this. So it's still valuable to take a look at what that is. And I can proactively go and we can look at this. I can click on this link and it'll take me to the details about that. And we can say, oh, well, we're not vulnerable to that. We could actually, through Snyk's tooling, we could ignore that with a comment. We could, have other mitigating things. We could patch around it if we wanted to. There's all sorts of options. But Snyk's name stands for "So Now You Know." It's an acronym. If you didn't know that.
Mm-hmm.
And it's now you know. It's rather than just blindly checking something in and say, "Oh, YOLO, hope that works." Well, let's make sure this actually did work though. So we've built the container, we've scanned it, and now we're going to push it up to our ECR registry. That pushes those layers up. And then all I'm going to do to deploy it is I'm just going to take the deployment and scale it down to 0 replicas and back up to 1. It's set to auto pull new images, so that will trigger a pull of the new image. Oh, come on. Push, push, push. You can do it, Cloud9.
It's not a problem here. Let's check, see if we've got any questions here.
I don't see anything in QA. I have not been able to follow chat, though.
Yeah, I'm looking at the QA. I'm in the chat, and someone did say it's a shame it couldn't be longer. And I say sometimes we do these sessions over 2.5 hours. This is quite a compressed one, but you will get the video, and you'll also get the link to the workshop to do on your own as well.
Yep.
There's lots of different types of workshops that we do at Snyk as well. Some capture the flags, some different live hacks, and now we're even doing one about AI in developer security as well, which happens quite often. So always look out for these interesting sessions around Snyk where you can join and learn more about being more secure.
Marcus, that's a great question. What's the advantage of scanning an image over a Docker file? Well, a Docker file is just instructions. And using linting tools on Docker file, I totally say you should. So there's tools like Dockle or my brain's gone because I'm in demo mode right now, but HaloLint that both will take a look at your Docker file itself and tell you about best practice, but it's not going to know what packages transitively are getting pulled into a base image, a final image, which is what the scanners do. The scanner will go in there and it'll actually walk the tree and look at your Debian or Alpine or whatever packages and look for those vulnerable bits. It also is looking for fingerprints of known issues. Canonical, and I like to bring up my buddy Brett Fisher at DockerCon showed that Snyk is able to find a node image that he CP'd into basically a small, tiny image. But because the fingerprint of that vulnerable version of Node was in there, it's one of the ones we watch for, and it found it and flagged it. Okay, we've scaled our thumbnailer service. If I do a get pods, we should see it's running. And 26 seconds ago, good. So now if I try to, I'm going to remove the result PNG just so we don't have anything in here. I'm going to try to upload again that encoded one. And now I'll try to decode. Same. And our script cannot find the hacked, the data, the element that should be there if the exploit was working is no longer there. So we've resolved that, and it wasn't anything to do with my Python code. You should scan your Python code, and we have tools for that. As Paul talked about, you should scan your packages that you're bringing in with PyPI or whatever you're using. But in addition to that, you need to pay attention to what your containers have, because that's the part of the iceberg below the water that you might not know about. So that's the first bit. So
yeah, and in your own time, you can read more about the specific hack. We've got some bit more information there about how it is, but we are pressed for time.
Yes, any registry, any Docker compliant registry, pretty much that you would have heard of, we support. And you can see the images locally without a registry even involved.
Yeah, Dockerfile or Docker images locally or in registries. Can it be used on Docker Slim images? Yes, it can. In fact, we use this to actually scan a Docker Slim images just now. Was it, Eric?
Yep. That wasn't a Docker Slim image, but it can. And we actually have a partnership with the Slim AI folks. They just were added to our technical partnership list. So expect more collaborations with them coming forward. Stay tuned to the Snyk YouTube channel. I bet you there'll be Snyk Lives coming with them.
Always something changing.
Okay, so next we're going to show you the GitHub integration side of this, and I'm doing this first so that you can see it, and then we'll show the exploit that we're going to solve with it. So when you set up your Snyk account, you probably were presented with a page something like this that will ask you to set up your integration. For this demo, we are using a GitHub repository, so we're going to integrate with GitHub. I've already done this because it's kind of takes a bit of a minute or two. You're going to configure GitHub, which is going to have you authenticate with GitHub, and it'll give it the access, and you can tell it if you want to give it public, private, or both repositories. But then you're going to get to the part where you're going to add the project. And there's like 3 different ways to do this. But I'm just coming into my projects area here, and I'm going to click either of these 2 add projects, and I'm going to choose GitHub. And I have a lot of orgs, sorry. It's scanning through all of my repositories, and the goof one is what I want. So I'm going to choose that and add selected repository. And at the moment it says 0, in a minute we'll start seeing it cycle through. And what it's doing is it's going out and there we go. It is inspecting that GitHub repository, looking for any projects that we know how to scan. That includes Docker files, as far as it's going to look at the Docker file and discern what it can from the static file itself, mostly the base image information. It's also going to look at Maven projects. It's going to look at, in this case, it's a Java app I'm doing. So Maven project, Gradle projects, Node.js, all sorts of different projects that we know how to scan. It also will trigger, you might have to turn this on, but if you have it turned on, it'll trigger the Snyk code SAST scanner, which looks at your bespoke code and tells you if there's security bad practice in there, and IAC files. So here we go. It has scanned through it, and you can see it's found a few Docker files, a bunch of Maven files. It did do, I do have Snyk code turned on, so it did static analysis of some stuff, and then a bunch of Kubernetes YAML. I wish I had time to go through all of it. We're going to take a look at the package scanning capabilities of the Maven package, and just do this as a teaser. Hold on to that. Now that the scan is done, we're going to move forward, and we'll come back to this in a second. So remember, we have 2 load balancers. We have the to-do list load balancer as well. And that is going to point us, if we grab what it outputs. Oops. I'm going to get out of the thumbnailer directory. This long name with the / to-do list at the end will take you, I don't have it already open, so let me just open a tab. And my browser, if I don't type HTTP, it will be unhappy. We're not set up secure. So it'll take you to the front page of our huge money-making cash cow application for our company, to-do list.
Huge revenue.
Huge revenue maker, big money maker. We're going to log into it with my super secret username, foo@bar.org, with the password foobar. Oh, did I say that out loud? There we go. So there is our application. And you can see that if I were to do a search in here, let's say I do car, it's going to show me all the items that have a car, or mom. Buy a gift for mom. If I search for something like Eric, there's no to-do list with my name in it, so that nothing came up. But this is a demonstration of log4shell. And I'm going to copy this string and paste it in. And I'll talk about that string in a second. And you can see I searched for $curly brace JNDI LDAP, blah, 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 blah. And all of a sudden I got this nice container you have. And it is everywhere in my application. So I have graffiti sprayed all over my app. What has happened? So I don't have time to run through a full detail of how log4shell is. It's kind of out of scope, but this application is obviously using a vulnerable version of log4j. That what the exploit on log4shell is that it blindly interpolates JNDI addresses and queries the network for LDAP servers to get remote configuration. Usually is what that was implemented for. But because of the way it's implemented, it was an evil server, as you saw earlier, could take and reply with the URL of another server that has bytecode precompiled and ships it back down, and my JVM will blindly just run that bytecode, even though it's not something that was in my application to begin with. And the bytecode that I'm returning knows that this is a J2EE, Tomcat type app, and it is modifying the header JSP to put that in there. very innocuous and easy thing to do here, but it's very simple to do the same thing and get a remote shell into it. And I do that on longer form demos. So how would we have caught this and stopped it? So put yourself back 2 years ago, about this time 2 years ago, how would I have known about this when it was announced on December, what is it, 18th, I think? Well, if you were scanning things with Snyk's GitHub integration, even if you hadn't touched this code in a year, all of a sudden, when that CVE was opened, if I opened this Maven project, I would have gotten alerted by email and other means to the fact that there is a remote code execution exploit in the log4j core. And I'm going to show more detail on this. So this web interface is similar to what you saw on the command line. You could get the same stuff on the command line here. This is showing me in the application itself that's in the container I deployed, we have a library that is bringing in a vulnerable version of log4j. I can see that we have a 1,000-point scoring scale for issues that we find in things. This is 800. When it was new, it was a 1,000. It's the first time I ever saw a perfect 1,000 because it was easy to exploit. It was prolific. It was to be talked about on socials all the time, and all those kinds of things come into play with our research team. We have a large research team that goes through all of our vulnerabilities and adds metadata and helps to set these scores. So right now it's at an 800 because it is mature. There's a fix available, and it has a CVSS of 10, which is as bad as that can be. Because this is a very prolific one, there's a ton of stuff. I can click this and go, there's actually an entire learning page we have on, oops. There we go. That is going to walk me through what it is, how it is, and actually through like an example exploit of it. But what I care about is I'm notified of this now. How could I fix this? Well, most of our issues that we find, if it is fixable via a upgrade, whether it be a Maven dependency in this case, or in a Docker file, a base image upgrade like we saw before, there's usually a button here that says fix this vulnerability. And this is showing me everything it's found. This is a very old repository. Lots of bad stuff in here. But in the amongst, there it is. It has checked that one. I could check more. I'm not going to for this demo. And I'm going to scroll down and I'm going to say open a fix PR. This is going to go back to your GitHub repository and open a pull request with the fix to the POM file, the Maven POM file, for this problem. There we go. In a nicely formatted, commented table with everything in it, so that you wake up in the morning and you have this pull request sitting here. Oh, hey, I should look at this. We can automatically do this as well. So by default, we'll automatically check every day and email you if something like this comes up. Or you can turn on auto pull request and you'll wake up to a full-on pull request that has run through your pull request automation, your regression tests, whatever else you do. And you can see what has changed is we upgraded the version for you. Now you can review it and you can take it if you want to. You can not. I'm going to go ahead as I'm kind of going off of. I haven't been following my script, but we're going to review this thing and we're going to accept this for the sake of this demo. Say that, oh yeah, we've tested it all. Looks great. So we'll merge this in. Confirm merge. There we go. And we'll go to the next page. So now we're going to go and we're going to pull that down to our Cloud9 environment. There we go. And
while you're doing that, I mean, Eric, what you were saying before is very important. Even if you're not changing the code, or even if your code's stable, new vulnerabilities, lots of new vulnerabilities are found every day. And that's why Snyk scans your applications every day and can automatically create pull requests. We're there to help you scale your security effort.
Oops. I did not CD into the right directory. Sorry. I've got a bug in my script. So if I will fix this, but if you run this, you need to be in the to-do list directory. All right. Yeah. Oops. Sorry, folks.
So hopefully people will be able to work that one out.
As soon as we get done here, Paul, remind me. I will update the instructions and have them regenerate the workshop to have that.
Will do.
My bad.
I think we've done this workshop at least 10 times and just noticed that.
Well, I said you need to remind me.
Yeah.
That's why I knew what it was immediately. It's like, oh, I've seen this before. So here we go. And imagine this, of course, this kind of stuff would be being done, through your CI system as well. You wouldn't do all of this through your local, your merge is going to trigger a build. It's going to cause this kind of things to happen. There we go. So we've pushed the new version up, and we'll do the same kind of deployment scaling down and up to have it redeploy. And let's do git pod just to see if it's up and running. 6 seconds, it says it is. I'm going to do logs on to-do list just to see what's output. Catalina startup is done. So now let's go back to here and let me force a refresh so it knows we've got a new instance and all my cookies are cleared and everything. Sign in. At r.org. Watching the clock. Sign in.
I think we're doing very well, actually.
Copy that nasty string again. And sure, you tried to search for it, but I'm no longer vandalized because we've nipped that now. That log4j library no longer is vulnerable to it, just by simply updating it to the fixed version.
Yeah, I've had a few people confusing the fact that it did contain the search string and broke out the header in the past, thinking that was the hack. But no, because we're not able to change that header JSP, that means we're now not interpolating those JNDI strings.
Yeah, and to be clear, the application itself, all it's doing at the point where that search is happening, it's doing, if you're a Java programmer, you've used log4j, it's doing a log what was searched. It's saying user searched for X, and behind your back, log4j is doing that interpolation.
That's all log4j is supposed to do, isn't it?
Yeah. So it was a feature implemented in like 2013 to do remotes configuration, I believe, from directory servers. And nobody really thought of this apparently. And sure enough, so that fixes that. That is actually the end of the demo for now. And like I said, we do have this other module on chain guard images and how you could use those to even further harden that thumbnailer example we had. Feel free to do that on your own time. But now, if you're using your own cluster, your own resources, go clean up, go shut down everything, because we don't want to be responsible for you.
Cost or security.
Yeah, that actually might not be the right. This is for if you're in the AWS workshop. But yeah, delete your cluster,
destroy
your repositories, do all the cleanup you need to do. And again, don't deploy the goof app somewhere that is important, because that's gonna not your security folks are not going to be happy with you. With that, I'm going to stop my screen share.
Excellent, Eric. That was absolutely fantastic. And you got through it in time. It was still clear. Hopefully now you've all got the confidence to look at that workshop, use the video to go through yourself and really understand some of these vulnerabilities. But just to go over what we've learned today, right? As Eric said, if you don't know there's vulnerabilities in your code, whether it's the container or the application, that's the first real step that you need to make. So Snyk's there to help you with the visibility. So now you know, it's in the name. We want you to get you to understand what's actually in there. And we don't want you to fix things on the cloud by clicking a button, updating a container in your cloud environment. We want you to shift left. How do I fix the Docker file? How do I fix the container, the application on the container? How do I fix the Terraform or CloudFormation? And then redeploy a more secure app after that. And then finally, automation. To truly scale your security effort as a team, you need not just the security team, but the developers involved as well. You need that automation, whether it's in automated pull requests, scanning in every CI/CD, scanning the applications that are live every single day, even if they're not changing. Because there's so many things and variables changing in the world, the automation's there to make sure that you don't miss anything. All your applications and repos are scanned, and any change that goes into that code base is scanned before it's merged in. These are 3 things we've really shown you today, and hopefully you can go through that and kind of find out yourself a bit more about these vulnerabilities. On top of that, Snyk is available on the AWS marketplace. Using your AWS budget or EDP spend, you can go and sign up for that. If you're just a single developer wanting to learn more, again, Snyk does have a freemium free tier, so please sign up for that. And one of the best things about the free tier really is the access to the Snyk Learn platform. Learning about certain types of vulnerabilities, whether it's the OWASP top 10 or the Snyk top 10, learning how to hack them and then learning how to resultantly fix them makes you a better coder, makes you a more secure coder, more confident coder. Okay, so are there any more questions that we have before we call this a day? Let's just see what's in there. I think the Q&A is still empty. The last chats are just saying how much of a good job you've done there, Eric, which is always nice to hear. The feedback's always appreciated. We love doing these sessions. Hope they're all useful. I think with that then, we will say thank you very much. Please go and try Snyk, make your code more secure. And if you've got any questions, please contact us and try that workshop for yourself.
Paul, where can they go if they have questions with the workshop?
Oh, okay. We do have. Do we still have the Discord? I can't remember that. Or
Yes.
is it now? We have the Discord. If you've got the link to that.
Yeah, let me get that for you.
Where we have a number of our community members helping. This workshop with those 2 repairs that we're going to do to it, however, just after this, Eric, will have no problem. You'll have no problem following.
So yeah, Snyk sponsors DevSecCon, which is a community for DevSec, and we have a Discord server that we use for our DevRel team. Other folks on the company are in there. Feel free to jump in there, and the community in there would be happy to help. If you have specific product questions, I think the front page of Snyk.io, the little help lozenge at the button is the best place to ask those kinds of things.
Yep. And you can always reach us on LinkedIn as well.
That's always true.
So if you've had time, hopefully, to copy that DevSecCon community, get involved, which will have our Discord link, you can go and speak there as well. But yeah, please let us know how the workshop is and how you've done. Thank you very much, everybody.
Thanks, everyone.
Bye-bye.